Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Panama Buena Vista Union School District, and Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
I'm Devin.
And in studio with us we have Charlize, and if somebody needed to contact us, Charlize, what would they need to do?
For the math homework help, call in Bakersfield 636-4357. Everywhere else, 866-636-6284. Email dothemath@kern.org. We're online at dothemathonline.net, and social media, Facebook, Instagram, Twitter, and YouTube.
All right, nicely done. Thank you for taking care of that for us, because when Devin and I try to do it, it just doesn't come out as smoothly as that.
I start speaking French, it gets weird.
So, Charlize, where do you go to school and what grade are you in?
Fairview Elementary, and I'm in 5th grade.
How is Fairview?
Good.
It's pretty good? Have you been there for a long time?
Yeah.
So what is their mascot, the Fairview
Falcon.
Falcons? All right, that's a nice mascot. So what do you like best about 5th grade?
I don't know.
Anything in particular? I mean,
We get to do art.
so you get to do a little more art this year than in the past, and you like doing the art projects and stuff, right? All right, good. What are you looking forward to? Because this is like the midpoint of 5th grade, right? We're like kind of right in the middle of the year. So is there anything you're looking forward to when you go to 6th grade? Will you still be at Fairview, or is that a middle school you'll go to different? Or will you
A
still?
different middle school.
So you'll be going to a middle school. So are you kind of nervous about going to another school since you've been at Fairview for a long time, right? It'll be kind of exciting though, don't you think? All right. What kind of math are you working on in 5th grade right now?
Multiplying fractions.
Multiplying fractions. So we're going to do a little bit of that later on, but what we're going to do right now is take a look at today's problem of the day. You ready for this? All right, let's take a look at today's problem of the day. And Charlize, this is what people on social media had an opportunity to work on. So have you ever had to find the area of something before?
Yes.
And what does it mean to find the area? Do you know what that means? Like how you do it?
No.
Let's take a look at the problem once again. So a lot of times when you see a figure like this, a rectangle, it might ask you the area or the perimeter. So if we wanted to find the area, what are we looking for on that? Do you know what we're looking for?
Like the outside of it?
That would be the perimeter, is the outside of it. So if we don't want the outside of it, we're going to want the
Inside?
inside of it, right? So we have two numbers. Do you have any idea what we might do with those two numbers?
You're gonna multiply.
There you go. We're going to multiply them. So what is 7 times 4?
7 times 4 is 28.
There we go. And we know that since we're doing area, it's going to be in square inches. So the correct answer is C, 28 square inches. And sometimes students might get perimeter mixed up a little bit, which is why some of the other options are up there, but nicely done. First problem done. See how easy that was? There you go. You're well on your way. 636-4357 is the phone number. We do have phone tutors available until 5:30 this afternoon, and a couple of other surprises up our sleeve. But first, let's take a look at today's Math in the News. All right, today's Math in the News has, you know that it is a new year, right? What year is it?
2023.
There you go.
Are you still writing 22 as your date when you have to write that out still? It takes me like 3 weeks to get used to that.
Well, I don't see she's writing bills and things like that yet.
Okay.
So that's interesting. Do you ever have to write the year on anything you do at school? It's usually maybe
Really?
the date,
Right, the month and
right?
the day, but not the year.
never the year. I don't remember ever having to do that when I was in school
No,
either.
I had to do that. Yeah.
Well, you were in accounting class in kindergarten and moving on from it, so you had to do a lot of that kind of stuff.
I was the headmaster of the No.
Oh, there you go. See, I want
At
the
that
year on
stage-
this. Back in the 70s,
Lay
right?
it out. Oh, you're
So
kind
anyway, ooh, got the
70s,
buzzer
he
on
said.
that. Hey, the guy
70s,
doing
he
a buzzer
says.
I know was alive in the 70s,
70s,
also.
everybody.
All right. So anyway, do you stay up until midnight on New Year's Eve? You do.
Oh.
There you go. You stay up later than the old man does. Anyway, so do you watch the ball in Times Square? Do you watch that on TV at all? You just stay up until midnight. You guys are doing celebrations and things like that. All right. Well, one of the big things is a lot of people go to Times Square, and I strongly suggest if you can go once in your life to this event. It certainly is worth going to. So the history of the ball started with sailors needed to set their instruments, and that's how this whole thing started. And we can see the good mayor of the city back a number of years ago.
Name your boy. That's Ed Koch, right?
Yep, that's him. And then we can see the early days, but this thing has evolved into quite the spectacle now. And we can see that the ball today is 12 feet in diameter, weighs close to 12,000 pounds, has over 2,600 Waterford crystal triangles. And I went, when we were in Waterford, Ireland, went to the factory where they do this Waterford crystal. Fascinating place and all of the different things they do there, but that's a different thing. So the triangles cover between 4 3/4 to 5 3/4 inches. They're bolted with a lot of LED modules and lights and things like that. And it's just something to see. If you haven't seen it, I mean, a lot of people see it on TV, and it's one thing to see, but when you're actually there, it truly is a sight. Just like the Christmas tree at Rockefeller Center. Same thing. I mean, you see that on TV, but you don't get the magnitude and you don't get the feeling of how big that is.
You see it on TV.
The atmosphere of everything around
It's
also.
the atmosphere more than anything else. Scope is everything. You expect to see this massive tree, and it's a tree. It's 90 feet tall. You can see a 90-foot tree. The ball is a spectacle up high. You got to see it. It's far away, and especially with all those people around there, that's what you go there for.
And the one thing is, I need to caution you because some people might go, "Oh, I want to go." Okay, once you go and you're in there,
You're no getting out.
you're staying there.
No
you
way.
cannot leave. Okay, so you might get there at 5 o'clock in the afternoon, and you'll have to wait until midnight. You're in an area that is penned off,
Basically a pen,
and you're in that until it's. Once you leave, you leave. You're not getting back in.
Any other needs you may have.
Now
you
that
better
came
make
about
sure.
after I was going.
Okay.
Because back in the 70s,
The 70s.
that
Back to the
stuff
70s.
didn't have
okay, right?
but anyway, we move on. So let's take a look at the shape of the ball. All right. So it's a geodesic polyhedron, and a lot of students may have heard of geodesic domes and things like that. So it's a convex polyhedron. And there was a time not too long ago when the World Cup started, we were talking about truncated icosahedrons, which are soccer balls. And you've seen those before, right? You've seen a soccer ball. Yeah, okay. So we're talking about the geometry behind the ball for New Year's. And then the last thing we were talking about that day, and we're also talking about it today, is if you unfolded it, it would become a net. So I know that you're in 5th grade right now, but have you ever even heard of the term net in mathematics?
No.
All right, well, guess what? In 6th grade, you probably will, but I guarantee you in 7th and 8th grade and when you do geometry in high school, you're going to be familiar with a net. So it's like taking a soccer ball, or in this case, the New Year's Eve ball, and if you unfolded the whole thing, right, and laid it flat, that's what it would look like. That's a net. Does it kind of make sense now? All
So
right,
technically, it's not even really a ball. Because we think of a ball, we think of a perfect sphere. So even though it has a similar shape,
right, because it's all triangles.
exactly.
There we go. And that is today's Math in the News, and happy 2023 to everybody out there. All right, well, I did say that we had a couple of other things up our sleeve, so let's bring one of those things out right now. Come on to set. And right up here, young lady. So this is Kiki, and there are a lot of you going, well, Kiki has been part of the show, but we don't remember seeing Kiki too often, right? Because I think you've been on air once or twice before? Okay, so to go back a little bit, when did you first start with Do the Math?
Okay, so I want to say I first visited the show
There we go, let's do that.
when I was in 3rd grade.
Okay, so you were in 3rd grade, so you were about 7, 8 years old. How old are you now?
I'm 18.
Okay, so it's been a decade that we've had you around Do the Math.
Yeah, and your daughter, Mackenzie, who's just across the way, was right there at camera 2, and
Okay.
she put on the headphones on my head, and I got to like listen to our technical director, Brian, and I got to like watch the show. It was really cool.
And that was the spark.
Yeah,
So then you started hanging around a little more.
yeah.
All right. So then you were employed by Do the Math. And what was your role when you were with the show?
I did a little bit of everything.
I was going to say.
I came in my freshman year of high school. I was 13, and I started in audio, and then I did floor directing, and then producing.
Okay. So speaking of audio, floor directing, and producing, you said one of those people that got you into this was Mac, and I think we have a shot. Yeah, there's Mac right there. So
In the fishbowl.
there's Mac watching right now, and she didn't expect that one right there. So you left us,
I did.
but for better things. So what are you doing now? Because you're 18, you have graduated high school, and where are you now?
Now I'm going to Seton Hall University in New Jersey, and I'm studying to be a nurse.
There you go. So that's a big step, and congratulations to you, first of all, for getting into Seton Hall.
Thank you.
That is not an easy thing to do. How are you experiencing East Coast life? Because Devin and I have done that and kind of
Swapping
grown
the
up there and
opposite,
things,
basically,
Oh, yeah.
and have come west, you're going east.
Well, everything they say about the pizza is true. It's
Good.
fantastic.
I told you, you know what?
They
People
don't
always
understand
like,
here.
oh, no,
They
no,
don't
no.
get it. That's right.
Hey, unless you have it, you don't understand.
That's right.
There is not pizza out here. They have what they
No.
call pizza.
It's flatbread with
It's-
tomato sauce on
It's
it.
so
so
doughy.
continue on. I like the first thing you said. We didn't prompt you about this at all.
No,
Right
not
on
at
the
all.
money.
There we go. So pie is essential. All right,
Oh,
so
yeah.
continue.
Public transport is really awesome there.
Right.
It's so where I am in New Jersey, it's just across the river from New York City. So it's like 30 minutes, like $7.50 to take a train straight into Manhattan.
Right.
It's perfect. I love
Okay,
it.
so you're off in the center of Manhattan.
Yeah,
right.
right at Penn Station next
Right.
to Madison Square Garden.
Yeah, because it's actually underneath Madison Square Garden, so you're there and
Yeah.
you can go see a show if you want to. You don't even have to get out of, go out into the
outside.
elements at all. So how are you with the cold and snow now?
Well, I saw snow for the first
There
time
you
falling
go.
from
Good,
the
good,
sky.
good. Falling, oh, a miracle
That
has
was-
happened, right? Snow
Run.
falling from the sky.
I was like a kid in the candy store.
There you
I
go.
was like, oh my gosh, wow, it's snowing.
So now we come to the important thing. So you're at Seton Hall University. You're enjoying everything on the East Coast. You experiencing some different. You're experiencing weather now.
Yes.
You are taking advantage of culinary favorites back east. What math class are you taking?
I was smart enough, I tested out of most of the math classes, so I didn't take one last semester, and now this semester I'm taking statistics.
Very good. I was going to say you're not going to get through a whole year without taking any math, but you
Yeah.
tested out and were able to go into stats. And for nursing, how many other math classes are you projected to be taking during
Just
this time?
stats, just statistics.
That's it. But I know a kid like you will probably take another one, just so that you have a little more math background.
I mean,
You don't have to answer that right now. It's all fine. I'm only kidding you like that. So you're enjoying everything back there.
absolutely. I'm
All right.
enjoying classes, the people, everyone.
We are certainly glad that on your visit back to California to see your family,
Oh, yeah.
that you came back to see you do the math family
Oh,
as
yeah.
well at the same time. So thank you. All the success to you moving on from this point forward. I'm sure you will be. You've been a very successful kid up to this point, which is why you're at Seton Hall in the nursing program right now.
Yeah.
All right, nicely done.
Thank you so much.
Hey, we do have phone tutors available until 5:30 this afternoon, but every once in a while we did to go out and about throughout the community and see how they use math in the real world.
here at the Bakersfield Police Department Traffic Division, talking with Officer Burdick today, and we've got Officer Clayton off to the side waiting for us. We're going to talk about collisions and accidents and how they use a lot of tools to measure force and acceleration and all those kind of things out here in the real world. So welcome, and
Thank you.
Actually, thank you for having us, I should
thank
say.
you for being here. Happy to have you.
And so go ahead and kind of give us a little bit of a sense of where we are and what we're going to do.
Yeah, so we're here at the Bakersfield Police Department training grounds for driving and motorcycle training. I'm sure you'll kind of see around and in the background all the cones set up. That's where we're at, so we've got a collision staged here, and hopefully I can help walk you guys through it.
As far as the tools that you use, what kind of things will we be seeing with the tools?
Sure, so typically when our officers respond to a collision scene, it's just occurred. Normally it's hopefully no injuries, but sometimes more minor injuries, and that would be a more basic investigation, not really requiring too many tools. But myself and Senior Officer Clayton are a part of a major collision investigation team where we kind of get to break out some of the more fun tools on those more major collisions. And those things help us measure braking efficiency, acceleration, and also to diagram our scenes so that we get every piece of evidence accounted for.
Fantastic. So what are you looking for when you first arrive to a scene? What is it that you're looking for in the environment initially?
So anything that helps us to identify how the collision occurred. So we want to look for gouge marks in the roadway that might show us where this area of impact was. Any friction marks leading up to or away from the scene that would help us to gauge the vehicle's speed, both approach and departure, as well as just any debris or fluid in the roadway. And then the evidence of just the injuries themselves might help to lead to determining crash severity.
Okay, so you were talking earlier when we were talking prior to getting on camera about the force and impact and like hats and shoes, or you're kind of learning a little bit about how the movement, if it was a person that was hit in an accident.
Right, yeah, just kind of the kinematics of how people move during a collision, whether it's a pedestrian, you might see different types of trajectories, and even just occupants in a vehicle tend to move parallel and opposite to the principal direction of force involved in the collision. So yeah, that definitely helps us to determine how this collision occurred just based on how the injuries were sustained.
So a lot of physics.
Yeah, lots of physics.
Let's go ahead and we'll look at what we've got set up right
Sure.
here.
So here we've staged a collision, and we have just a typical rear end collision at our cone intersection here. We've also applied the brakes. There's some skid leading up to the car, and what we've staged here is just a rear end collision. This Fusion was stopped at the limit line and was rear-ended by the patrol vehicle.
Fantastic. So would there be a lot of movement, because she's currently into the intersection, would there have been a lot of impact and push into that, or would her brakes kind of sustain it and there's just a lot more force?
Sure, yeah, and it obviously depends on the force, right, required to move a mass. So if this patrol vehicle is doing 100 miles per hour, you could expect this car to be pushed much further, into or even through the intersection. And if this patrol car is just kind of rolling at 5 miles per hour, there'd be very little, restitution or rebound within that collision.
Fantastic. So we're going to learn a lot more about the tools
absolutely.
and whatnot in another segment. So back to you in the studio.
All right, thanks for that, Cece. Also, thank you to Zach and the rest of the BPD for inviting us out and learning a whole lot about what goes on at intersections, the braking and things like that. And we were talking about some of the tools yesterday. You were able to go out and check out with the bomb squad and stuff like that. So a lot of things. Thank you once again to everybody over at BPD. In the studio, we have a 5th grade student from Fairview Elementary, Charlize, and she is ready to do some work. You ready?
Yes.
All right, so you're working on multiplying fractions. So head over to the board with Devin. We'll take a look. You've already done some of your homework while you were waiting, and we can see that you were multiplying mixed numbers. But number 7, it says, using the example above, and we'll have to look at that in a second, it says the new highway will be a total of 54 miles long. Will the highway be completed in 8 months? So we have 8 months to do 54 miles. Now, if we go back up, we can see that they can complete 5 3/5 miles every month. Okay, so every month they can do 5 3/5 miles. So I think that's all the information you're going to need to know. So you want to see if you can do 54 miles in 8 months.
So with this information, we know that we'd like to get to 54 miles in 8 months. What would your approach be as far as figuring out whether this is possible? Before we write anything down, what are you thinking about this?
We would multiply that times that.
So when we say that times that, what are we specifically referring to?
5 3/5 times 54.
Okay, so you're saying we want to take a look at the total miles here that we can complete of this highway in 1 month. And you want to multiply this by 54 miles. Now, let's be clear, the 54 miles is going to be the total length of this highway. Once everything is done being built, this is how long it's going to be. Now, this crew can build 5 3/5 miles of highway in 1 month. So if we think about this kind of like a diagram, right? Like this is our first month, and this is going to be 5 3/5 miles. Ultimately, we want this to be 54 miles. Actually, let's do this up here. Let's make sure that things are consistent here. When we're using diagrams, it's always important to make sure that everything stays the same. So we want this full highway that's going to be 54 miles to be completed, but we need to do it in 8 months. So how can we figure out if we'll be able to complete this in 8 months, if we can complete 5 3/5 miles in 1 month?
You multiply 5 3/5 by 8.
We can do that, right? Because what should happen if the highway is going to be complete is it could be 54 miles or it could be more than 54 miles, right? So let's go ahead and do that. Let's do 5 3/4. Let's move this down so you have a little bit more room there. Let's do 5 3/4 times
3/5.
8. Oh, 3/5. You're right.
There you go.
Absolutely. Thank you. Times 8. Show us how you do that.
First, I would make the 8 a fraction.
Okay.
And then I have to multiply the 5 by 5 and get 25, then add 3.
So you're converting 5 3/5, which is a mixed number, into an what some refer to as an improper fraction. Okay?
And I add the 3 and I would get 28, so I would write it down here.
So 5 3/5 is equivalent to 28/5. Now, before you did that, you converted 8 as a whole number to a fraction, 8 wholes. And the reason you did that was so that you can multiply these two fractions together, correct? Let's go ahead and do that then.
And I need to bring the 5 right here, and then multiply that. And we do straight across, and 28 times
And so
8.
let's talk a little bit about straight across with multiplication, because I think it's something that students are taught to do, but they don't understand why. Something to keep in mind is what we're essentially doing with these fractions that we're multiplying is we're creating a new fraction, right? We're creating 28 times 8 divided by 5 times 1. And so the reason that we're able to say we can multiply by going across is because we're essentially creating this new fraction that involves multiplication. So let's look at this, right? 28 times 8 over 5 times 1. Which of these do you think you'd want to do first?
The bottom.
You'd like to do
5
the
times
denominator, right? Why do you want to do the denominator?
Because it's easy.
It's super easy, right? It's one of those identity properties of multiplication, right? Anytime we multiply by 1, we're like, oh, let's do that. So 5 times 1 is what?
5.
5. Now, we can even start setting up down the line for when we work this out, right? We are going to divide this. So let's go ahead. Whatever this ends up being, we're going to divide it by 5. So let's just leave that over there for now, okay? Now, for 28 times 8, that's going to require a little bit more work, right? Show us how you would work out 28 times 8.
28 times 8. 8 times 8
This is one of those square numbers, right? So 8 times 8. Is there a way we can break this up maybe into smaller multiples of 8 that we're friendly with? So if we think, for example, of 8 times 8
You want a
as,
drink of water real quick, Charlize?
Need
There
that?
you go.
So I'll talk things through as you work on that. So we can also think of 8 times 8 as 8 times 5 plus 3. Because we know 8 times 5 and we know 8 times 3. And we just combine those together, right? 8 times 5, that could be 40. And 8 times 3 is 24. And so that we know that we combine those together, we get 64. So we'll have that 6 in the tens column there.
And then we did the 8 times 2 and 16, then add that.
So we have 16 plus
22.
6. 22. Okay. So we know that 28 fifths times 8 whole is 224 fifths. Now, we're going to divide. Now, we don't have to get an exact number here. Our goal is to see if this ends up being 54 miles or more. So if we divide this out, and how we have it set up, this lets us do this really quickly. Let's do 5 into 22, and that gets us to, how many groups of 5 can we get into 22 tens?
4.
4, right? So equivalent to 40. Now that's really interesting right off the bat, right? Here's why. We could process this out and work through and do all of the long division process. But remember, we need this to be 54 miles or longer. Do we know already if this is going to be 54 miles or greater? Yeah, we know. We know it's not going to be, right? Because what is our tens place here?
4.
So we know it's going to be 40-something. It's not going to be 54 because it's not even going to get close to the 50s. And we'll continue to work this out. It'll still be 44. This might go on forever. This might be one of those repeating decimals where if we keep subtracting, it could go on and on and on. But we know that it's going to fall short. So is 8 months enough time to build out this highway?
No.
One thing that we can also think about as well, before working this all out, so we can do a little bit of reasoning too. If we know that we have 5 miles in 1 month, let's even estimate, right? If we do 5 miles in 1 month, that would be 40 miles in 8 months. Do we think that 3/5, 8 times is going to get us there to get to 54? Probably not. So there's a lot of different approaches towards solving this problem, but we went with the most direct calculation method.
All right, there you go. So just reasoning through it and estimating is one way to kind of take a look at that and go, all right, it's going to be 40 and you're not even at 6 because 6 times 8 would be the 54, but nicely done. So for your great effort so far this afternoon, young lady, you've got yourself a meal courtesy of our friends at Chick-fil-A, so congratulations on that. Do you have a favorite thing you like at Chick-fil-A?
No.
You like it all? Good, just like me. I'll eat it all. It's all good stuff over there. Anyway, we do have another opportunity to go out and visit the BPD with Cece, and we'll see what's going on with the traffic division right now.
Thank you, Mike. We're back out here again, Bakersfield Police Department with Officer Burdick, talking about collisions and how they go ahead and measure impact force, skid marks, and all that kind of stuff. So go ahead and tell us what we're going to be seeing with these tools.
Sure. So we've been here at the scene for a minute. Everything's stabilized. Now it's time to start documenting our evidence. And so the first thing is we're going to want to diagram where everything is in our scene, and the best way to do that is with our laser scanner, which I'll show you now.
Officer Clayton, you're going to walk us through this, right?
Yes.
Fantastic.
This is a Leica RTC 360 laser scanner. It's got a few different components. The screen's here that will tell you how much time is left, where to start it. You can change the settings, whether you want it to take photographs, the amount of points you want it to take. And it takes millions of points per second. So this laser, the laser's in here in this ball, you'll see when it turns on, that ball will start to turn really fast, and that laser is constantly taking points as it turns. The device will then start to make a turn this way, and will make a 360 degree turn while continuously taking points to make a three-dimensional scan, measuring distance and where that point is throughout the entire scene. It's got a few cameras on it as well. You'll see 3 cameras here that will take 4K photographs again in 360 degrees throughout the entire scene to document everything. It's then got 4 additional cameras here and one on top that will that it's constantly tracking stationary objects within the scene. So it's not gonna be able to scan things that are on the other side of the car unless you move the device. So when I pick it up and move it, and I move to the other side of the cars, it knows where it's at in the scene, and it can overlay the 2 scans together to make one 3-dimensional world.
It's very smart.
Yeah.
You also said that sometimes, especially like in this intersection, we've got a lot of skid marks, that you mark things. Talk about that a little bit.
It's not always that just one collision happens in one intersection. Sometimes we have intersections that have collisions all the time. So you may have skid marks or tire marks that aren't related to the crash that you were at that time. You've got to be able to identify which ones are related to your collision based on where the cars have ended up, statements from the people there, other physical evidence, gouges. So we'll mark where each mark starts and ends and kind of where it tracks so that I can easily identify and mark it on the computer later on once I render this 3D world.
Fantastic. I guess we want to see how it works.
Yeah. So you'll see on the back here on the screen, it has 1 minute and 51 seconds on there. That's how long it's going to take for this scan. The first 51 seconds as it's spinning smoothly, that's when it's taking the 3D points with the laser. Then the last minute of it, it's taking photographs. It's going to be increment movements as it takes the photographs around. So I'll go ahead and start by hitting play, and you'll hear it start to boot up. As it makes that 360 there, the visual cameras on the corners are tracking where it's at within the environment, and it's getting its reference points to know where it's at. Aside from diagramming this, we also have our event data recorder or crash data retrieval device over here that Officer Burdick's going to talk about.
So this here is our Bosch crash data retrieval tool, or CDR tool. There's a couple different models we have here, but this is the older of the 2 that would be compatible with a vehicle like this. In this collision that we've staged, there's not a lot of damage, so we can still access our OBD port, or the diagnostic link connector DLC port, under the dash, which is where you'd typically retrieve any diagnostic codes. So we'll plug this in under the dash. The other end would be USB to my computer, and I have software on there that'll allow me to run the program, and it'll pull any data, if it exists, from the collision we're investigating. So if it has enough what we call delta V, which is a change in velocity experienced during the collision, it'll register with the airbag control module, which is designed to determine crash severity and whether the car should deploy airbags or not, depending on how bad the collision is. So in something like this, if it's just a little fender bender, it might not register an event, but the more severe the collision, you're probably going to see an event recorded on there. In the event that we have so much damage that we're losing power, we can't get it hooked up to the battery to get juice to it, maybe the dash is intruded, in that case, we would have to go direct to module. And that's where the fun begins, is we're at the tow yard with the Sawzall, and we start cutting the center console open, and we're actually looking for the airbag control module that's mounted to the frame.
Fantastic. So there's a lot more to learn.
Yep.
All right. Well, we're gonna head back to the studio, and we'll talk again in a bit.
All right, thanks for that, CC. We see the trundle wheel moving along right there. We do have phone tutors available until 5:30, most Tuesdays and Wednesdays throughout the regular school year. Phone numbers and email are always at the bottom of the screen periodically throughout the program. And in studio with us, we have Charlize, a 5th grade student from Fairview Elementary. You've been at Fairview for a long time, getting ready to go to middle school next year, though. All right, you ready to do the next problem? All right, let's take a look at it. So, Syed, we'll just call him
Syed.
Syed.
There you go. Yeah.
Right? Gave an answer of 6 6/7 for the problem 4 2/7 times 1 3/5. Using estimates, is this a reasonable answer? Now, both of these are just simply yes/no questions, but I'm sure your instructor would like it if you explained a little bit after it, right? So we know that the first one, no, 8 months is not going to be enough time to fill that highway in, right? So this one, they want you to estimate. And how are you with estimating? You feel pretty comfortable with that? All right, so let's put some numbers up on the board, and you guys can estimate those and see where we're at. So first of all, it says they gave 6 6/7 as an answer. And the problem was 4 2/7 times 1 3/5.
So, as far as reasoning and estimation is concerned, we want to see whether this is a reasonable guess, whether it makes sense that it could be this answer, not whether it is that answer. So we don't necessarily have to do any multiplying yet. But estimating with these types of values can be very useful. So when you think of estimation, as it pertains to mixed numbers, what comes to mind, or what are your thoughts initially? What might you try? Okay, how about this? How could we think about this? It might help if we think about what friendly numbers these seem to be close to, right? So let's get close to each of these. 4 and 2/7. What is 4 and 2/7 close to? What number would you say 4 and 2/7 is close to?
4 as a whole?
4 whole. Wonderful. What about 1 and 3/5?
1 whole?
We can say 1 whole, right? Okay. Let's look at this. 4 times 1. What do we know for 4 times 1 to be?
4.
4. That's interesting. All right, I'm just going to go ahead and create a number line with some of our answers here, okay? So let's say 4, because for both of these, it seems like we estimated close numbers that were lower than each of these values, right? So we're going to say this is 4. I'm just going to write for reference 4 times 1, okay? What's another close number we could use instead of 1 for 1 and 3/5?
2?
2, right? So 4 times 2. What do we know for 4 times 2?
It's 8.
4 times 2 is 8. So I'm going to put that here on this number line too as well. 4 times 2 is 8. Now just a sense here. We know that 4 times 1 and 3/5 should fall where on this number line? It doesn't have to be exact, but generally, where can we expect 4 times 1 and 3/5 to fall? If we know that 4 times 1 is 4 and 4 times 2 is 8, 4 times 1 and 3/5 should be where? It doesn't have to be an exact answer, but like just with like a show of a marker, where would you draw that line for where that could be? Oh, that's a great estimation. It's not quite going to be a half because we know that 3/5 is larger than 1/2, right? So we know that 4 times 1 and 3/5 should be somewhere around there. We also know what should be, if this was 1.5, 4 times 1.5, what would be halfway between 4 times 1 and 4 times 2 if we know that 4 times 1 is 4 and 4 times 2 is 8? What would be halfway between those two?
6.
6, absolutely. Now, based off of what we understand with number sense and reasoning, is it reasonable that this might be 6 and 6/7? If this is 4, and let's just add a little bit here, 4 and 2/7 times 1 and 3/5. Is it reasonable that this could be where 6 and 6/7 might be?
Yes.
I think that's a fair, reasonable. Now we could work this out to be more precise. We can do 4 and 2/7 times 1 and 3/5. Let's go with your method here of converting these into mixed numbers and then rearranging that to figure that out. 4 and 2/7, let's make this 30/7. And let's multiply that by 8/5. We have 30 times 8, that's 240, divided by 35. And we can skip count here. We can go by 35s. We have 35, 70. We have another for 105. We have another 35 for 140. We can keep going. We'll get close to 6 and 6/7 as we keep going up. But is that a reasonable guess? It sounds like it is. Is it exactly that? We'd have to work out a little bit more to make sure. But the question's asking, is that reasonable based on estimates? And I'd say that's a fair estimate.
There you go. And that's all they wanted you to do right there was estimate. So what you did was perfect. You went 4 times 1, 4 times 2. In the middle, you know that 6 is going to be there. And the answer that they gave was pretty close to what you said was 6. And you actually marked it pretty close to what it would actually be right there. 636-4357 is the phone number. We do have phone tutors available on Tuesdays and Wednesdays. And there was something that you did before multiplying mixed numbers that you said you need a little bit of help on, right? So let's take a look at one of the problems that you have in the book. And this is where you have a grid and you're shading in part of it and putting dots in part of it also. So, Devin, would you like to, let's start with number 1.
Sure.
All right. So we can see that here we have 3 vertically. So we have a column and we go over 1, 2, 3, 4, 5, 6.
Okay.
So we have a 3 by 6.
3 by 6. Great. All right. I'm going to use this type of rectangle up here just for the sake of illustration. Okay. And I want to make sure I see this. I don't know how well that visual of the dots coming through is.
Right. Don't worry about it because you got a 3 by 5 right now, but.
Do we have 3 by 5? No. Okay. Let's go ahead and fix that then. Make sure we get this exactly right. So we are looking at a 3 by 6 grid here. All right. Phenomenal. Now we see that the bottom 2 rows are shaded in. Now here it has shading and dots. I like to utilize color in these types of situations to help this make sense, right? Firstly, we have a rectangle that represents 2 different fractions that are being utilized here as part of a whole. How many rows do we have in this table, in this rectangle?
3.
3. That represents one of our fractions here, okay? This is going to be a multiplication problem. How many columns do we have for our other fraction here?
6.
We have 6. Wonderful. Now, on that first diagram, we have 2 rows filled in and shaded. For the sake of our illustration here, I'm actually going to go ahead and highlight this instead of shade it. So I'm actually going to use a blue highlight here. And I'm going to do that so that we can show how these rows and columns can interact with each other, okay? So, Charlie's question here, how many rows have I shaded blue?
2.
2. Wonderful. I have 2 rows shaded blue. Now for our columns, it has dots over here. Again, for the sake of illustration, I'm going to use another highlighter color, and this time I'm going to use yellow.
Now you may not be able to see them, but all 3 have dots.
All
in
3
that first
in
row.
that first column.
Column.
Correct. So let's go ahead then and color all of the cells in this first yellow. Okay? Now, of the columns, how many are shaded in yellow?
1.
1, exactly. Now, an interesting thing about these 2 colors, which you've seen here with this overlap, and you've probably done this with highlighters, right? Sometimes when you have a bunch of highlighters and you want to start making new colors, you just combine 2 together, right? I'll color one over there. You can do that here as well. I have 2 questions for you. First of all, how many cells or how many rectangles do we have in this whole rectangle broken down together? We have 3 rows and we have 6 columns. So how many do we have in total?
18.
18. Now, an interesting thing happens when we combine blue and yellow, right? We end up with green. So my question to you is, how many of our 18 cells are colored in green?
2.
We have 2. So we have 2 out of our 18 cells that are highlighted green. Now, we were talking about how to multiply fractions earlier, right? Now, the quick way that we generally do that is just by multiplying across. But why do we do that? Well, take a look at what happens with these two fractions? If we were to just multiply them across, 2 times 1 equals?
2.
And 3 times 6 equals?
18.
Now, one of the more contentious elements of fractions, I'm on one side of the fence on this one, is in regards to representing fractions in simplest form. I would posit that it's not always necessary. However, in a situation like this, we can talk a little bit about why it might be a certain way. Let's consider this. We have 2 out of these 18 colored in green. Instead of thinking of this as 18 individual blocks, what if we break this down into groups of 2? And we figure out how many of these groups of 2 we can make out of this whole rectangle. So how many of these sets of 2 rectangles do we have altogether? So let's see, 1, 2, 3. You see what we're doing here?
4, 5, 6, 7, 9.
So we have 9. Now my question here again is, if each of these represents 2 rectangles, how many of these 9 are colored in green?
1.
Just 1. Absolutely. And that's why we see here that 1/9 is equivalent to 2/18, because it still represents equal portions of the rectangle shaded and filled in. So what we're saying here through that diagram is 2/3 of this horizontal, of these rows filled in, shaded blue, times 1/6 of these columns, highlighted yellow, overlap in 2 out of the 18 figures in this rectangle.
Nicely done. So Devin, you were great at being able to get that grid up there. Let's get rid of that one and put up a 4x7.
Phenomenal. Let's do 4x7. Let's see, 4x7. Here we go. Did I get it right there? 1, 2, 3, 4, 5. There we go. 4x7.
All right. So we've got, you can take a look at this. We've got a whole row. Well, let's go with a column then, because you've got 7.
Okay, yeah. Let's
do the whole first column.
Here we go. Let's get this 7x4. 7x4. There we go. All right.
All right. So the whole first row has a dot in it.
Phenomenal. So let's do that. Should we change up colors? Let's change up the colors a little bit, right? I like combining colors. What 2 colors do you like to combine together to make a new color?
Pink and blue.
Pink and blue. Ooh, I wonder what happens when you combine pink and blue. Let's do that. All right, let's see how well pink comes through on this. All right, let's do a pink highlighter. And we're going to go ahead and highlight that first row here at the top. Okay. Wonderful. All right, so our first row is filled in with pink. Now, what fraction does this row represent? So how much of the rectangle did we fill in pink?
1, 2.
Well, we have rows, right? How many of the rows are pink?
1.
Out of?
4.
4. 1 out of 4 rows are shaded pink. Excellent. Okay. Now, let's take a look at our columns. And let's see how many of our columns are filled in on that diagram.
5 columns.
5 columns. Great. Now, we're going to fill that in blue. Let's go ahead and choose our blue. And we're going to fill in our 5 columns here. 1. That's an interesting result there, but we'll work with it. 2, 3, 4, 5. All right, so we filled in 5 columns. Now, how many columns are there?
7.
7. Excellent. So we have 1 out of our 4 rows and 5 out of our 7 columns. So how many rectangles, how many sections do we have in total in this rectangle altogether?
28.
28. And how many of them overlap with both the pink and the blue shade? To kind of give us a little bit of a darker
5.
blue here. 5, exactly right. So what this diagram represents is 1/4 multiplied by 5/7 equals 5 5/28. Now, are there any common factors that we can use to simplify or reduce this fraction to a simpler form? I don't think so, right? 5 is a prime number. It can only divide by itself and 1, and we know that we can't divide 28 by 5. So we can just leave that there as it is. This represents 1/4 times 5/7 equals 5/28.
Nicely done. And hopefully, Charlize, that helps you out with what you were just doing, and you said you need a little bit more help on understanding that. So does that help? Using the colors and doing it like that? All right, nicely done. Hey, you know what? We do have one more opportunity to visit with the Bakersfield Police Department. Check out what Cece is doing now with the Traffic Division.
We are back out here with Officer Burdick, and we've been talking a whole lot about skid marks and accidents, and it's all about energy and what happens, that transfer of energy as you're getting into a collision. So we're going to walk through skid marks at this point, right? We're going to measure some out? Okay.
So in our staged collision here, we had our patrol car slamming on its brakes, and it left locked wheel skid marks. We can measure it. I brought a couple of tools here which we would use for measuring. In our typical day-to-day crashes, our roll meter here is a lot more handy. You've got other traffic still coming and going, but when we've got the roadway shut down to do a major collision investigation, we can kind of take our time and use more precise instruments like this one here, just a regular tape measure, and this one goes up to 300 feet.
Okay.
And we can lay it out, take all our pictures, but for something like this, we'll go ahead and use our roll meter. So what we've done here is we've come all the way back to where we can first see our skid marks. And if we start on this side and kind of look in the direction of our car that was braking, it helps us to see the skid marks better than if we were to stand on the other side looking back toward us.
And why is that?
And that's because of the irregularities in the asphalt. There's very microscopic hills and valleys, and as the tires are getting hot and sliding in one direction down the road, all those hot pieces of rubber are depositing on kind of that north face of those hills, if you will. And so it becomes more visible to us if we're standing in the direction that it was traveling.
Okay, fantastic.
So just reset this to 0. We'll find where our skid starts, and you can see it kind of just fades into existence. And that's what we call impending skid. So we'll find kind of the start of where our skid mark is. Normally we would mark it with chalk or paint, and that would also help with our Leica scanner. But I'm gonna say that I see it first, right about in here, and I'm at 0. And I'll roll this out. And this is just going to give us our total length of the skid mark, which will help us do some math later. So about 61 feet.
Okay, so you said you're going to have to compare this though to using your accelerometer to figure out how fast this vehicle was going.
That's right, and that's because if this vehicle was not very capable of braking, he could maybe be doing 30 miles per hour and take 60 feet to stop, whereas a high performance, Corvette or something might be able to do 60 miles per hour and stop in the same distance.
Okay, so you're going to show us how that works?
Yeah.
Fantastic.
Let's hop in and check it out.
Okay, so this is the accelerometer.
This is it.
All right, fantastic.
Yeah, so as we talked about before, this is just going to measure the longitudinal, lateral, even the vertical X, Y, and Z components of the vehicle as it's moving down the road. So basically we're just going to mount this, and for the purposes of our stage collision, we're going to pretend that this is either the same vehicle and it's still operable, or maybe if it's so badly damaged we need to get a similar vehicle, so another patrol car maybe, and we're going to lay down some test skids so that we can get some of the values we need to determine how this vehicle was capable of braking and how fast it might have been going at impact.
All right, let's do
So
it.
first we're going to mount this here to the windshield. All right, so we're set up and ready to go. And now we're going to have to go back to a position where we can set up our scanner, and so we don't crash into any other cars that are out here. So.
Fantastic, let's do it.
All right. All right, so we've moved our vehicle back from where it was initially at rest in our collision scene so that we can do our brake tests in the same area that our original vehicle had applied its brakes, so we get the most accurate reading here. So our tablet here is connected to the accelerometer, and it has all the software here that will allow us to view the printout of whatever our accelerometer determines here for us. So we're going to go ahead and start our setup here. And it's loading. And once this is done, here it is, it's now ready to start the test. So we're gonna go ahead and back up to where we can get to speed, and we're gonna apply the brakes right where we're at right now to get the most accurate reading.
All right, I'm excited.
All right. All right, so we've moved back even further now to the start of where we're gonna accelerate and then apply our brakes, shooting for around the same spot where we were parked when I initially set it up on the tablet. So we're gonna go ahead and start our test here. And now we're ready to accelerate, so we're all buckled up and ready to go. All right, so that's our skid test, and as you can see here on the tablet, it's given us a printout of a whole lot of useful information for us, including our speed, 31.8 miles per hour when we started braking, a distance of 39.2 feet is how long it took us to stop. And then what's more useful to us is the average G, or it's a constant of gravity times our acceleration rate. So it's going to give us 0.876 Gs is the average that we obtained while braking. And with that information, we can go back and do some math to figure out how fast this person was going when they applied their brakes. If he was speeding, then we can do some what-if calculations to figure out if he could have stopped and avoided the collision had he been going the speed limit, and a whole lot of other stuff. So lots of implications from this, and we can go and apply it and do some math to figure out.
So we don't have to do it again to try and get the exact skid. You've got it all right
well,
here.
ideally we would do maybe 3
Okay.
to get an average,
Okay.
but that's basically how it works. We just do it a couple more times.
Okay, let's
and
back
pick an
up and do it
average.
again. No, just
All right, yeah, whatever you want to do.
All right, we want to thank you so much for having us out today. This has been fantastic.
Yeah,
so
of
this
course.
is for you
Thank you
guys.
so much.
Thank you for being on Do the Math, where math and the real world collide.
That's right.
Right, all
Hopefully
right.
not colliding too hard.
There you go. Thank you so
No
much.
problem.
Yeah, nice to see that they collide, but not actually collide. But John was just talking about how he had the camera in the back of that vehicle right there, and it's a little different when you're holding a camera in the back with a piece of glass in front of you, separating the front and back seat right there. But just a great application of how mathematics is applied with the Bakersfield Police Department and the Traffic Division, and the software that goes into that program. Have you ever thought about doing anything with computers when you get a little bit older?
No.
Well, you know what? Maybe something to think about. One of the fastest growing industries is software development. And right now, people start at over $120,000 a year, and it's ever growing, software developing, coming up with programs so that different businesses and industries can use them and stuff like that. So have you put any thought into what you might want to do when you grow up? I know you're only in 5th grade right now, but
No, you got time. Don't worry about it.
plenty of time?
Yeah.
All right. So the rest of 5th grade, what do you think is going to be the best part about the rest of 5th grade now?
I don't really
You know what you don't know? You know what it is going to be? It's going to be you telling other kids about Do the Math. Can you do that for us? All right, so you're going to be an ambassador for us. What you're going to do is you're going to tell everybody about Do the Math. Sound good? All right. Hey, until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Panama Buena Vista Union School District, and Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.